whenever you're ready. Okay. So thanks for coming to the event. As the abstract said, it mentioned, basically we're going to be talking about two things, which is Kojak, a project that I've been working on at Red Hat, and also a broader discussion about just developing in an open source environment and what that entails and the differences between the different communities and getting your code into those communities. So really no major slides, but a few memes. You know, what we're doing here is not rocket science. And it differs from company to company, obviously. There are some principles which I hope to share with you guys today, but mainly I think for me is to try and give you a bit of background about what happens in Red Hat and how we build software, specifically in my business unit, which is middleware. Basically, we have a number of tools that we use, and there's a drive that we have right now internally in the company to try and get people to adopt those tools in order to make barriers of entry to open source contribution lower and to encourage the adoption of those tools. So I know we just spoke a little bit before about your experiences there, and it kind of aligned with the way that I also experience things, which is it's hard to get into open source projects if you're not in a particular company or an institution which is very, very active already. So one of the things that I would like to try and encourage is Joe Bloggs at home is interested in a particular project he wants to contribute code to. How can he do that? So in an easy way, in a really easy way. And this is one of the drives that we are going to do. So my business unit is middleware. I work with a product called JBoss. JBoss has over 300 open source communities, different groups of people, different cultures, different sizes, different numbers of people, basically different ways of doing things. And one of the tasks that we have for release configuration management, which is the team that I work in, is how do we get this project that's out in the wild that we want to now include in our product, which as a Red Hat offering has to be supported, has to be certified, has to be documented and go through a quality assurance process. And so there's a number of things that we need to do when we pluck source code outside of the community and then we put it into our shrink wrap products and sell it onto the open market. And in doing that, one of the pains that I had was identifying the tooling that we have to use, what's the best ways of putting things together. And so I thought that after a while, when I was asked what would you want to contribute back to Red Hat, I thought it would be a good idea that I can save someone all this time when they join. So like basically bringing the onboarding time down of a release configuration engineer. And in so doing, the project Kojak was born. Now, what is Kojak? Basically, it's a virtual machine, it's a virtual appliance, and it's got a bunch of the tools that we use in Red Hat and our upstream Fedora. And basically it was just capturing these tools, installing them onto a platform and making that platform available to whoever wants it. So all of the source code that you're going to see here is freely downloadable, and it's on my GitHub. All the details I will supply later as well, so you can access all of this stuff freely. Let's jump in, because basically what will happen is that you can go ahead and just download this software from my GitHub account, which is basically just git clone. Again, all the information I'll give to you guys at the end of the talk. Essentially, once you've downloaded Kojak, it's worth mentioning that right now it runs on Linux. Fedora, I'm running Fedora here, but it'll probably run on Red Hat as well. So if you are thinking of using it, you'll probably need a working Linux installation somewhere and with Git. And you need some root access. But once you've downloaded it, you can simply go into the directory, and there's a very simple executable in there, which I can fire up. And it gives you basically a bunch of options that you can use. Now, if you already have a running Linux installation, you can just go ahead and run the install option. If you don't want to do anything with your Linux install and instead create the virtual machine, which is the way that most people would do it, that's the option that you would do there. And obviously so I'm going to go through the create VM option, and you have a number again of basic options. There's a default installation, which is the one that I've captured, the most common thing, so you don't really have to think about too much about what it is that you're doing. You can customize it if you wanted to, and really the customization gives you options like changing the name. You can do where you want to save the image. So it gives you some variables there that you can mess around with when you're coming to create the actual virtual image. And most of these, again, you don't have to worry about. It's only once you start playing around with it, perhaps you might want to change the amount of memory you allocate to it. Maybe you want to change the disk size. Maybe you want to install it somewhere else. I've captured the most common things that I thought would be useful. And you have that option to do it there. But in this instance, we're just going to go straight away with the default option. And it's going to go off and it's going to fetch some bits and pieces for us. And now, while that's going, I'm going to explain a little bit about the toolset. So basically, at the heart of Kojak is a program called Koji. And Koji is the build system that we use in Fedora, and we use a version of it in Red Hat called Brew. Basically, it's our build system, and it builds RPMs, it can build zips, archives. Basically, it packages our source code. And this is the bit that, for me, was the one that I really wanted to get exposure for outside of Red Hat. You can go ahead and start using Koji in Fedora. You need to create a number of accounts. You need to get someone to vet the code that you submit. So it's not an easy process. And often what happens is people go down the road of trying to do this, and then they give up, because it's just, they have some source code, they just want to package it, and it's just too much hassle for them, especially when there's no incentive outside of their own motivation for wanting to do it. So there's no financial maybe incentive for them to do it, so they don't persevere with this. And that was the key thing I wanted to do. I wanted to bring Koji, and hence Kojak is basically Koji in a box. And that's at the heart of this system. There's other tooling, as if you're Java developers, we use Maven for the project management. We use Jenkins for the continuous integration and delivery. And we also have a number of internal tools, which is a Jenkins plugin to Koji, which saves you trying to understand all of the nuances of the Koji API. And it's basically a plugin in Jenkins, which captures the most common options that you will need. And one of the things that we're doing with all this tooling is putting it together, as I said, on a platform and configuring it for you so that you don't have to have too much of an understanding of the back end. Hopefully you'll use it and you'll want to get an understanding, but in this instance, we just want to make sure you guys can just build. If you have source code, you just want to build it, and you want to see if that build would work in Fedora, for example, or in Red Hat. You have an opportunity of doing that without being reliant on any of our infrastructure or any of our personnel, or you don't have to interact with us in any way. If it works on Kojak, 99% chance it will work on when you submit that build to Red Hat, which basically means if you do submit that build to Red Hat, we're going to use it. We're going to be hopefully you're going to have it a lot easier, because you don't have to run through this, backwards and forth of please change this, please modify that. If it builds on your Kojak system, you should be able to submit that binary, or at least the sources of that binary in the build configuration, and it will probably get accepted. So that's what we're trying to achieve. Now, just a quick thing about this. This goes off onto the internet, and it tries to download all the different components that I talked about. So again, you don't really have to worry about any of this. The speed of your internet connection obviously has a bearing on this. Again, as the development goes forwards, there will be an offline installation option as well. But pretty much once you've downloaded it once as a VM, you can begin snapshotting it and making sure that you have backups of a pristine Kojak installation. So if you ever trash the one that you're working on, it's okay. You can just go and pick up from a snapshot. One of the things with building software at least from my point of view, is that I want to be free to be able to break things. And this is a really useful thing for me in order to be able to learn, which is something that you don't want to be doing if you're using the Fedora build system or the Red Hat build system. You know, if you want to, and you probably wouldn't even get the opportunity to do so because those configuration files are you know, you won't have access to them. So it's in a kind of nice jailed environment for you to do whatever it is that you want to do. So now, while that's doing its thing, once this gets installed, the workflow that we currently have or that exists for a community builder is you go to the community website, you download the code from GitHub, you read the instructions on how to build the software, you attempt to build the software, and if you're lucky, you build the software. Most often, you don't build the software, and there'll be something that's broken. And you will go through a certain phase of attempting to fix these build issues for yourself personally. And if everything works out, you know, it'll be happy days, and you know, your build broke, well, works for me, you know, and that's basically a lot of what happens in the community. If it works for you, you're not really care about what happens with other people's builds. That's not how it works when you go to productizing a build, or when you try to do it or release it as software in a shrink wrap product, because that's not good enough. You know, this build does not work for me is no good. This build worked 5 minutes ago is not good. And basically, oh, that's one for later. So, you know, what we're looking to do is to make builds that work consistently, that are reproducible, and to a specific criteria or a standard. And that's the pain of when you take a community build and when you try to make it into a product build. And hopefully this is what we're trying to reduce, that effort, because it's, in my work, I work with 2 other teams. So release configuration engineering work with the product engineering group, and they work with a productization group. And we're all ultimately responsible for, you know, producing and getting that software out. But the ownership of the criteria of what that software should meet is basically it's on our neck. So it's RCM that's responsible. So often, you know, if we don't fix a build, or we fix something and then we end up being responsible for all the other ones, that's not the way it should be, but that's unfortunately the way that it is. So in taking a build from the community and shoring it up to work in production, as I mentioned before, there's a number of things that we're really working with here, which is the support, certification, the documentation, and the quality assurance. How do we deal with those problems? Well, a lot of it is with tooling. I mean, the standards and tooling that's then implements the standards. And this can be a real headache for someone who's just building in the wild, because you may not have access to the documentation that describes the standards that we were building against, and you may not have access to the resources in order to do that. So again, it becomes kind of counterintuitive when you decide that you want to contribute code and then get told for all kinds of reasons that code is not going to get in. It doesn't bode well for us because we lose the effort that we could have tapped in on, and it doesn't bode well for you because you don't get to fix the problem that you were working on or that you wanted to fix. So I'm again hoping that if nothing else, we will hopefully be able to bridge a little bit of those problems and address them. And it's not always stuff that, you know, can be fixed immediately as such, but it's a growing thing. You know, sometimes it may be that those standards are not particularly clever or they're not correct. So, but we miss on the entire conversation. You know, we don't even get to go that far because you tried to commit code, it didn't get in, and you gave up. So I'm really hoping that, you know, we can get around that. It's just a little bit of more information about the tools. So as I mentioned, we've got Koji, or Brew, which is the actual build system. It's in charge of creating the final packages. Maven, that orchestrates the build. We have Jenkins for the continuous integration. The plugin, which is the Jenkins interface to the Koji backend. Git, We also have APROX, which is some repository management, which again, if you're familiar with the Java landscape, this works well with with Maven in allowing you to aggregate and split repositories for particular builds. So, and we have a whole bunch of Maven plugins which produce a lot of other information, like resolving dependencies when you do builds, providing build metadata for your project. So we've tried to capture all of the things that we use and that we would need in order to basically make sure that when you submit that build to us, it's in a certain place that, if it's not perfect, at least we'll be able to have a look at the logs, for example, and see what you're doing wrong and help out that way. Talking of which, I'll just mention really quickly the part of the Maven plugins. Maven is ubiquitous in Java world, and everyone pretty much uses it. Not everyone, but almost everyone. And then one of the nice things about Maven is being able to extend its functionality by plugins, and this allows us another area which is I have an interesting story about a requirement which we had at Red Hat in order to produce metadata about a build. So basically we needed to know who ran a build, how long did that take, what was the command line that they used for the Maven to execute it, what were the Java options, all this kind of information that would be useful for us to be able to track on builds. We had this requirement came up. And typically what happens is normally some genius would just run away and start coding this immediately. But because it landed in my inbox, and because I'm not a genius and I'm pretty lazy, I decided to go onto the internet and see if something else already existed which matched this criteria. And this is an interesting thing about how open source I think should work. So I find a number of tools and I go through the system and validate them, see if they're good, and I make a short list and I contact the developers of the tools that I find. Only one of them came back, and it was a company, a small consultancy in Germany. Two guys run this company, SmartX. They got back in touch and they were very pleased that someone was using their plugin, and they were very keen to see it gets adopted, and they're very keen to have it to help out with that process. And so this was an interesting thing with respect to open source working correctly, in my opinion. Those guys got back. We took the software on board. We agreed on an approach for its integration. We decided to fork the project. They remain as the upstream maintainer. I become the maintainer inside Red Hat, and now we're actively using that software inside Red Hat, and I'm hoping that it's going to get adoption. And if that happens, that's a great example of going out into the wild, sending an email, and actually having people respond and things work. And I think part of that is basically the way that they their kind of culture and commitment to open source, which is sometimes lacking in other projects and communities for whatever reasons. Could be they're overworked, underpaid, I don't know, whatever. But sometimes you send out those emails, you don't get the responses, which is a bit disillusioning. But we're going to remain positive. So after this, I hope to basically get more adoption, encourage development across the tools that I'm going to show you. And I think a key takeaway for us is to be able to produce a catalog of known working builds. That will make more sense once we run through a build example. Typically what you'll end up with is a Jenkins job, which will basically capture all the ins and outs of your build, because it's Jenkins that pretty much, along with Maven, kind of orchestrates the building process. And so if you build something and it works and you're keen on having it included in the next version of JBoss or whatever, Red Hat, one of the ways that we make it easy for you to do so is to send us your config XML. You don't have to send us everything else. Point us to your job configuration, and then we should be able to drop that into our Jenkins, and assuming that all the source code is available and it's online, I should be able to run a build and reproduce what you've done. And if it does work and if it does go through, it makes my life a lot easier. And I'm, as a maintainer of a project, I'm much more likely to be, in a very unambiguous way, I'm letting you submit a patch or a code, a part of code, rather than me saying, well, could you go back and change this maybe, or this doesn't really fit that. It kind of puts the ball a little bit back into the maintainer's field, rather than me giving out a set of ambiguous instructions on what needs to change, and then you scratching your head and thinking, well, it works for me. So hopefully that's one way we can get around it. Okay, so there you go, boom. Now we're into the system, and it's just a Linux prompt comes up. It's root and root. It's really secure. No, it's obviously, so you can change and configure that yourselves. But basically, you can log in with root. Once you've logged in, there will be another Kojak in there, and this time when we fire up the menu, we will just go for an installation option, which is option number 2, and hopefully it will go off now and retrieve. So in this first instance, we've just created a virtual machine. And if nothing else, you can use the Kojak scripts to create virtual machines that you can use for do anything you like, which is kind of nice. If you don't want to do anything else, you can just use it to do that. But once that's in, and that's all it's done. It's just gone and installed, at that point, a virtual machine configured with some networking options and some very basic configuration. This is where we actually start to install the guts of the software itself, and it initializes by doing an update. Then it will go off and actually get all the components, and then there will be a third option which will run after this is done, which is to actually configure the system. The reason for having these in separate tasks, as opposed to just, you could amalgamate all of this into just one task and have it fire off if you know that that's what you're going to be doing. The reason I split this up is because we found there was value in having the state of the virtual machine in different areas of development, so that we can change, for example, maybe we don't want to use Maven and we decide that there's another build tool that we want to use. Fine, then you can just go in and change it without having too much of an impact on everything else. And there will be updates that will allow the full thing to be installed as well. By the way, this is just what you're looking at right now is just bash scripts, so it's nothing more complicated than that. When we actually come to do the builds, Koji is written in Python, and there are a number of Python scripts that we use, or programs, for what, if you like, that we use for orchestrating the communication between the build and the Koji API. And there's also some Java involved in there as well, but that's mainly it for the Maven side of things. So we're really touching on Python, Java, and Maven. You don't need to be an expert in any of them in order to get this running. Like, you just need to know how to fire up a shell and execute some scripts, and hopefully it will work. Yeah, famous last words. But yeah, so now once this bit is done, and again, it shouldn't take too long. You are still dependent on the speed of your PC and internet, but typically it works fairly fast. Once this is done, we'll go ahead and do the configuration, and we will go and build the build metadata Maven plugin as an example Java, and we'll build it locally, and then we'll submit that task to see if it builds in Koji. And what will happen is it will build locally, and it will fail in Koji, because Koji has some stricter conditions that need to be met. But in this instance, it's just a bug. But I thought I'd leave it in there because it will give you a nice way of seeing what you need to do to debug that build. We won't attempt to fix it, but we'll just go through, and I'll show you where the logs are. So really just walking you through the workflow, so that you can then, once you take this, you can then go and grab any piece of source code, reconfigure the config XML job that exists for build metadata Maven plugin to whatever it is that you want to build, and then you can just try and run it and see if you'll probably always build, well, not probably always. It may build locally, and if it does, that's great. And if it doesn't, you will have to sort out that local build yourself. But then when you submit that task to get built onto Koji, if it fails there, you will have metadata that you can provide us, and allow us to get involved and help you debug that. And you're much, much more likely to get help if you raise a bug and you include, obviously, the correct data that's produced from the log files, rather than, just raising a bug somewhere. So again, we're giving you some access to tooling that should help you, if not fix the build, at least get some debugging process started. Let's do that. So that shouldn't have happened, but that was basically I'm applying a patch, and it's already applied. So yeah, I'll fix that. But you just have to tell it no, don't apply it. If you did apply it, I don't know what would happen. It would probably break. But that shouldn't happen. Yeah, it's worth mentioning this is a work in progress. And again, I definitely would like to get people involved to get using it and highlight the bugs. There was a recent new version of Koji, and that's why those patches had already been applied. So, again, there's Apache, there's Postgres, you can see there's Jenkins. Aprox was worth mentioning. Aprox is the repository manager, if you're familiar with like Nexus or Artifactory, and it's just a way of being able to aggregate and manage repositories, Maven repositories, so that you can pick and choose which repositories you want when you're satisfying dependencies for build projects. So that part is now done. The final step is really just the configuration, which is option 3. And again, so at that stage, we've just installed stuff. We haven't done any specific configuration at all. Again, why? Because it may be that you don't want to use the default configuration options I've used. So I've given you an option to just stop just do the installation, and then maybe you evoke your own configuration. Now, and the most part of the configuration that's occurring here is with the Koji system, and that is a full-blown build system. It's way, way over the scope of today's discussion, and it's also the thing that I've tried to hide from you guys. But it's definitely worth mentioning that a lot of the legwork that we're doing is configuring that back end so that you guys don't have to deal with it. But it's well worth investigating if you're thinking of contributing to Fedora or Red Hat, because that's the build system that we're using. But it's another thing entirely, like on its own. It's a big, big system. So this is just doing the Jenkins client. And again, it's pretty much grabbing everything from the product repositories that exist. So I haven't made my own repository of their products. I'm actually going to source, and that was a design decision as well, because we wanted to make sure that you could with confidence know you're grabbing the upstream version of the tool. And that's in all cases. That's whether it's Jenkins and you're going and downloading it from their site, or if you're downloading from our site. So let's just see. We've got a couple of sleeps here, because it does take a varied amount of time for this stuff to install, but hopefully it should all be good. How are we doing for time? Okie dokie. We should be done fairly soon. What will happen is I should be able to go to Koji. Okay, so this is the Koji build system, and we've out of the scope for this talk, but we've created and configured the minimum basic kind of configuration you need in order to test your build. I'll go really quickly through it, but you can see that there's like Maven's been in there already. you can see the tasks we're waiting on doing some of this. Again, you will not really interact with this, but I encourage, if you want to get involved with Red Hat or Fedora, to take a look at this. Okay, so configuration is complete. So what I'll do is I'll take you to somewhere that will be more familiar to you as Java developers. Now, so here we go. Your good old Jenkins GUI. You'll notice that there's a build already waiting for you. There's a little job there that we've already pre-configured. So the first thing that you would typically want to do is to build this, and you're not at this stage. You're just building it locally. If that all works, then you're good to go, and then you can submit it to the back and see if Koji builds it. So I'm guessing you're all pretty familiar with Jenkins, and again, you don't really have to be at this stage. This is the job that we've got in there, the build metadata Maven plugin. We're just going to go ahead and build that. This will execute the build with a pre-configured command line. We've captured all that, and you can check. You can see what it's doing here. It's just doing a straightforward Maven, resolving the dependencies. It's going to go ahead and do all of this. It shouldn't take too long. It will then give us a build status, and we will know if we're good to go. And if we are, we'll submit it to Koji, and then, as I said, there's a little bit of a bug and it breaks, and then I'd just like to show you the logs associated with that. And then I'll stop talking, and we can open the floor to some questions. Oh, if you have any questions, by the way, just feel free to intervene and let me know. But this is pretty much your bog standard Maven stuff happening now. So we've got a little bit of a build success.
You said that Kojak requires Fedora or Red Hat or something IBM-based. Is there any way to run it on something other, like other Linuxes or Mac OS X or Windows?
You should be able to run it on other Linuxes, although I haven't tried. So right now, I know it works on Red Hat, Fedora, and any Red Hat derivative like CentOS. No problem. It should work on Ubuntu and any other Linux. The main dependencies it has is with libvirt for the virtual machine. So if you have, and it will fetch those libraries. Now the only thing is right now is that it's going to go to CentOS repositories and download those RPMs. Yeah, that would need to be fixed. So basically, answer is, at the moment, no. But I'd love to help out in any effort that would get it out there. The key would be to, we know what the packages are. The key would be to pointing it at the correct repositories in order to grab the Debian files or OS X files. But in theory, because it's Python and Bash and Java, it should work. And then it's worth mentioning that the Koji build system itself, once you get that up and running, can spit out all kinds of archives. You know, it does Windows packages, RPMs, tars, zips, ISO images. I mean, it's really quite something. They're even working on getting some Android APK stuff going in there. So it's, once you have something like that and available to you, it's a really cool tool to play around with. It does take a while to learn. It's a bit of a steep learning curve. It's an enterprise tool, but well worth it. And there'll be a job for you at Red Hat if you know how to do it. You can have my job. So let's have a look at the koji.local domain. Oh, I wonder if, no, okay. So actually, that's right, this has changed. You saw that the build succeeded locally. Well, if it did succeed locally, it gets automatically submitted to your Koji instance. We decided that there's no reason that there should be any user intervention. So at this stage, we're pretty much now submitting the task into Koji. because of the way Koji works, it will grab the dependencies that it will create a list of the dependencies that was used in order to satisfy the build in Maven. It will use that list to go off and fetch the dependencies again, and it will tag them into a branch inside Koji that then we can use to run the build against. Now that's all the bit that you probably will never want to engage with, but again, it's worth looking at it because you'll see that these packages are being built as a result of satisfying the dependency list. And then once it's got all those packages and once it's built all those packages, well, actually at this stage it's just binaries. Once it comes to build your source code, that will be the last task essentially. And then you'll see in the task section here, you'll see the task coming up. This indicates that this is running through it, and you can see the ones that have passed. So you see, it becomes very, very transparent if your build is going to work or not. This whole stage we've allowed you to do rather than us doing it, and I think that has some advantages for both of us. So what you can do here, actually, I don't have to wait for the build to finish. What you can do is you can pick here. You can pick like say a binary that's been imported here. You can access the POM file, and there's the jar that you're using. Typically, when you have built something, you will end up seeing this very similar thing. There'll be either a jar or some kind of executable or whatever it is, an RPM that you're building. If it doesn't build, there'll also be some log information here. And typically, there's like a boot log, a root log, and you can use that information to send over to us to help us help you with your building process. And that pretty much wraps it up. I mean, I'm happy to open it up to any other questions that you have, because that's pretty much it. Well, I mean, while we do this, and if we have time, yeah, I think we should be all right. I'll show you the logs afterwards, but that's pretty much it. And I hope that gives you an insight into the workflow that we're hopefully trying to get people to encourage. One of the things, I mean, as Java developers, you're familiar with like Maven and with Jenkins. Is there any other tooling that you guys use which you think would be a nice fit for this?
Well, great is becoming more popular.
Yes. Yeah, our communities are definitely, some of them are taking it up. So that's potentially an option in there as well. Any other things? What do you think of the setup? I mean, in terms of the approach, or in terms of, do you have any comments or any criticisms?
Well, as a Java developer, I'm used to pretending that I can run my code anywhere.
Right. No, that's true. That's a...
Having that kind of work seems, well, superfluous.
Yeah.
We're just pretending that it's
Yeah, I think you're right. If you're, it's worth mentioning, if you're just developing Java code and you're not too bothered about whether or not it lands in someone's distribution, this is somewhat it's not necessary in that sense. This is really, although, you know, just as an interesting thing, but you wouldn't go down this road. This is really for people who want to get stuff into a distribution, and specifically Red Hat or Fedora or CentOS. So for sure, yeah, this is overkill for the so really it's worth mentioning that is the target market for us. It's really people who are interested in getting it to our distros. I think it still has some value, even if you weren't too interested in Koji, because I guess you can see it gives you an idea of how we're approaching it, really. So it's a very clear demarcation now between, this is what I'm building locally, this is what I've built in stage, and then the production is really getting it into our build system. So it's effectively creating a staging environment for you, and this is something that we didn't have. You would have to come straight from the wild and hope to build on a production system with all the constraints that has, and you wouldn't be able to do it, and then you would just disappear. So it's one of those things that we're hoping to encourage people to use. And so, I mean, and you mentioned with like getting code in before and then going through the thing. Do you think that this might have some value in getting?
Well, yes, that almost guarantees that
Mm.
the code will work on your system.
Yeah, yeah,
It doesn't guarantee that I follow your code standards and so on,
yeah.
but automating those parts seems well,
Y-
almost impossible.
yeah,
So
that's
this is a big step in failure, actually.
and that's an interesting point that you made with the coding standards, because you're right. I mean, a lot of the projects, even in the communities, they have different standards, and so when it comes into Red Hat, there is some level of standardization, but really, again, we have to produce tooling for that. But that's an interesting thing to do, to be able to produce some tooling to vet the coding standards of what you've supplied. Yeah, I'll take that on board.
Well, there are check style and
Yes.
stuff like that. So
Yeah.
having those
Evoked.
configured
Yeah.
would be very helpful.
Yeah,
But
noted.
I don't think it's pretty much possible, because when you take the code in from the wild,
Mhm.
you adjust your style to it,
What,
as
what,
opposed to just say no, no, no. You have to, if you want to have it here in Red Hat, you have to
yeah,
format it. It's not. I don't think you do it.
we no we
You really adjust.
we pretty yeah. But you know what happens? A lot of the communities they do use those check style tools and stuff. When it comes into Red Hat, and this is from my experience, from the one when I brought in the build metadata Maven plugin. I didn't run any tooling to enforce any check styling. We did refactor, so I had to refactor it. So when that occurred, there was eyeballs reviewing it, but there would be nice to have that automated. I mean, I don't know if it creates a lot of extra pain for a poor Java developer, but at least on our side, it would guarantee some kind of formatting, at least on
There are
standards.
tools for it
Yeah,
in Eclipse, for
in
example.
Eclipse.
You have one. You provide a template, and then you reformat according to the template.
That would be kind of something that I would see if we were to do it, would probably occur at the Maven level, like a Maven plugin for check styling. But that would definitely be worth taking on board. See, that's I think for us, because just getting the thing to go through was such a pain that we were willing to let go on the coding standards. But yeah, that's definitely worthwhile. There's a whole bunch of stuff, I think, with the plugins that allow you to extend it. Okie dokie. Well, it's coming up to 16:45, and I have to finish by get out of here for 7. So I hope that you've had an insight into it. Help yourselves to beers and drinks, and I'm going to be around for another 15 minutes. So.